Uh, Today we will discuss how to do systematic analysis of any unknown organic compound. In this semester, you have analysis of compounds containing alcoholic group, phenols, and aromatic hydrocarbons. So the experiment will involve systematic analysis of the given organic compound, identify the functional group, then prepare a suitable crystalline derivative of the compound, and then identify of the compound. Okay? So, whenever you do systematic analysis of any unknown compound, it consists of actually 7 different steps. Uh, the first is the preliminary investigation, which where you will determine what is the color of the compound, how does it smell, what are the physical characteristics, whether it is a solid or it is a liquid compound. Okay, those things you will know. Next comes the solubility test. In the solubility test, it is a preliminary test which tries to categorize compounds into acidic, basic, or neutral compound. We will go into more details of this. The next is the ignition test or the flame test, where we try to categorize compounds into aliphatic or aromatic compounds. Okay. Next is the test for unsaturation or presence of easily oxidizable group. So these preliminary tests actually give you some important information about the compound. For example, the unsaturation test will tell you if the compound has a carbon-carbon double bond or a carbon-carbon triple bond, or it has easily oxidizable groups like a phenolic group, okay, or an aldehyde group. This is important information when we go and do the detailed chemical analysis of the compound. Next, we determine the melting point or the boiling point of the compound based on the physical state of the compound. And then we do the functional group classification test. So basically, the organic compounds, they have been classified into 3 categories. The compounds which are containing no functional groups. Okay. Those are the hydrocarbons. Next is the compound containing oxygen functional groups. So you have alcohols, phenols, aldehydes, ketones, carboxylic acids. So in this semester, we are doing alcohols and phenols. The remaining oxygen containing functional groups will be taken up in the following semester. And then you have compounds containing nitrogen. So that will involve the amines, the amides, the nitro compound, and so on, which you will be doing in the following semester. Once you have identified the functional group present in the compound, the melting or the boiling point, will help you list 5 or more probable compounds in the plus minus 5-degree range of the melting or boiling point. Now, once you have this list of probable compounds with you, you can identify a common crystalline derivative for them, which has reasonable melting point, in the range of maybe 100 to 200 degrees centigrade. And that common derivative, once you identify, you take this unknown compound and prepare that derivative. So when you prepare the derivative and crystallize it, take the melting point of that derivative. So from the melting point of the derivative, you can go back to your table of probable compound and find out what is the exact name of your compound. That is the approach for identification of the unknown organic compound. We will now go into details of every step. The first is color. Now, when you go to third year, you will study spectroscopy in detail, and you will have a more rational explanation of why a particular compound is colored and why it is not colored. For now, you can know that the compounds which are not highly conjugated, they are colorless, and the compounds which are highly conjugated will be colored. So I have listed some functional groups here. By looking at the compound, you will know, whether the compound is a solid or a liquid compound. So normally liquids that we give are aldehydes, ketones, alcohols, esters are liquids. Whereas if you have solids, you have phenols, carboxylic acid, and many nitrogen-containing compounds like amides, higher amides, they are solids. Okay. So then we come to the odor. So you have to, bring the test tube containing your compound to slightly closer to your nose and try to smell the compound. Don't poke your nose inside the test tube. Certain compounds, they have very characteristic smell. For example, esters, they have a fruity smell. Okay. Benzaldehyde, it has the smell of bitter almonds. Cinnamaldehyde, it has a smell of cinnamons. But there are certain other compounds, which will have no characteristic smell. So please keep recording these things as you go along doing the preliminary test. Next is the ignition test or the flame test. So on a metal spatula, you will take few crystals if your compound is solid. And if it is a liquid compound, one drop of the liquid compound on the metal spatula and heat it on the flame. Okay, heat it on the flame. See whether it burns with a sooty flame or a non. Do not remove the metal spatula from the burner. Let it be there for some time. You will see if there is a non-sooty flame, the compound is aliphatic, and if there is a sooty flame, the compound is aromatic. Okay. Now you can see how the ignition test is being done. You have to take your compound in the metal spatula and you have to start heating it. Instead of heating at the bottom of the flame, better would be to heat at the tip of the flame, which gives you maximum heat. And do not remove the metal spatula from the burner until you see the fumes coming and that the compound has completely burned. Allow the compound to burn. And when the compound burns, please see what is the type of fumes. If you see non-sooty, colorless white colored fumes, that indicates your compound is aliphatic. And if you get these black colored fumes, that indicates your compound is aromatic. So allow it to remain in the burner for long enough so that the compound completely burns. That way you can identify whether your compound is aliphatic or aromatic. Okay, so this is the same test. Next. Let us go to the solubility test. There are three different solvents in which you have to do the solubility test. First is the solubility in water. Now, first of all, understand how you have to do the solubility test. You have done the solubility test when you were doing the functional group test in the last semester. Also, you will take about, say 50 milligrams of the compound or 1 or 2 drops if it is a liquid compound. Add 2 to 3 ml of the solvent. Shake it. Now, these are organic compounds. They do not dissolve immediately. Give it some time. Shake it well and then see. Now, if the compound goes into solution and you get a single homogeneous solution, then you say that the compound is soluble. If the solid remains at the bottom, or if you get two different layers, some oil, settling at the bottom, that indicates that the compound is not soluble. Now let us go to the specific solubility tests. When you put water, either the compound will become soluble, the solid will go into solution, or the oily droplets will get dissolved and you will get a homogeneous liquid. In that case, we say that the compound is actually could be carboxylic acids, small chain alcohols, small chain aldehydes, ketones, or phenols. So, the compounds which have polar functionalities like phenols, polyhydroxy compounds, alcohols, having more than one hydroxyl group, or carboxylic acid, which have carboxylic group, they are soluble in water. So if your compound is soluble in water, you say that your compound is polar. It has polar functionalities like the OH, the COOH groups. Then let us, the next test, categorizes the compound into acidic and neutral compounds. So you will have to take again 50 milligrams of your solid compound or 1 to 2 drops of your liquid compound, and then you add 3 ml of 10% bench reagent, sodium hydroxide solution, which is available on your benches, and shake it a little. See if the compound is going into solution. When you check the solubility in NaOH, what is important is after shaking it for about 2 to 3 minutes, you decant the supernatant liquid in another test tube and add a few drops of Fonck calcium. If the compound has gone in solution, when you acidify the solution, it will precipitate out. If you see the precipitate, or the oil, in case your compound initially was liquid, coming out, it indicates that the compound had gone into alkali. If your compound is sodium hydroxide soluble, then you say that the compound is acidic. The acidic functionalities which are present in your compounds are phenols and carboxylic acid. Okay, so for now, you say that the compound is a phenol. Okay, and if your compound is not soluble in either of these, then only we go and do this Fonck sulfuric acid test. Again, 50 milligrams of your compound or 1 to 2 drops of the liquid compound. Then add 2 to 3 ml of concentrated sulfuric acid, the bench reagent. If you see that the compound becomes soluble, the compound could be an alcohol. There are other functionalities which are soluble in Fonck sulfuric acid, esters, aldehydes, ketones, and aromatic hydrocarbons also, like phenanthrene. They will undergo a sulfonation reaction at room temperature, but they will undergo sulfonation with darkening. So you have to see how the color is changing, whether the solution is becoming darkened, it is being darkened, or there is no change in the color of the solution. That is also very important. So what happens here is we should understand the chemistry here. For example, if you have a phenol, okay, it will be soluble in NaOH. It is not, phenol is not soluble in water because it has a very large hydrocarbon portion. But when you dissolve it in alkali, it forms the phenoxide ion, which makes it soluble in alkali. But if there is no phenolic group, the compound is an alcohol. Alcohols are not acidic in nature. For example, you have ethanol. They are not acidic, so they will not dissolve in NaOH. Okay. However, if you add Fonck sulfuric acid to this, what will happen is it will form the oxonium cation. Okay. Because of the formation of these oxonium cations, it will become soluble in Fonck sulfuric acid. Okay. Next is the test for unsaturation. So we need to find out whether their compound has a carbon-carbon double bond or carbon-carbon triple bond, or it has easily oxidizable group. For example, phenols are easily oxidizable, even aldehydes, like benzaldehyde are easily oxidized. So the first test is the Bayer reagent test. You have to take 100 milligrams of your compound, dissolve it in 2 to 3 ml of water. Okay. Take very dilute, sodium carbonate solution. You can prepare it on your own from solid. And 1 to 2 drops of very dilute sodium carbonate solution you add to this mixture. And then you add very dilute potassium permanganate solution. Potassium permanganate solution is available in the lab is normally this color or this color. So you take 2 ml of that and dilute it with equal volume of water, bring it to this color. And then you add 2 to 3 drops of very dilute potassium permanganate solution to this. Shake. Whenever you mix two things, immediately you should shake. Immediate discharge of pink color of potassium permanganate and appearance of brown colored precipitate indicates that either your compound is unsaturated or it has an easily oxidizable group. Now we will understand the chemistry of the test. If you can see here, if you have a carbon-carbon double bond, KMnO4 on oxidation will give you a diol, potassium permanganate, and the brown colored precipitate due to precipitation of manganese dioxide. Similarly, if you have an aldehyde group, potassium permanganate, oxidize it into corresponding carboxylic acid salt, which is leading to decolorization reaction. Okay. Now, once potassium permanganate test is positive, you know that the compound is either unsaturated or it has an easily oxidizable group, because both these functionalities will give you the positive Bayer's reagent test. Okay. Next, we do the bromine test to find out whether the compound is unsaturated or it has an easily oxidizable. So for that, what you have to do is you have to take your compound, again 100 milligrams, add water. Depending upon the solubility of your compound, you can add water, or you can add acetic acid, or you can add carbon tetrachloride. Please check the solubility of your compound before doing this test. And then you add bromine solution in the corresponding solvent. So if you are taking your compound in water, you have to take bromine water. If you're taking a compound in acetic acid, then take bromine in acetic acid. If you take your compound in CCl4 carbon tetrachloride, then you have to take bromine carbon tetrachloride. Okay, add 2 to 3 drops of bromine solution and shake well. If there is no decolorization of bromine water, it immediately confirms that the compound had an easily oxidizable group. Okay, because the aldehydes will not react with bromine water at the temperature. Okay. However, if the solution is immediately decolorized, without any precipitate, then we say there is unsaturation, carbon-carbon double bond or carbon-carbon bond. However, if the solution decolorizes with white colored precipitate, then we say that the compound is a phenol. Okay, let us go back and understand the history here. So if you have carbon-carbon double bond, okay, it will be oxidized. Bromine will add to the carbon-carbon double bond, leading to decolorization. Similarly, carbon-carbon triple bond will undergo addition reaction to give you 1,1,2,2 tetrabromo derivative, leading to decolorization of the compound. Okay. And in case of phenols, what happens is if you have a phenol and if you react with bromine water, then phenols, the solution is discharged of the brown color and you get a white precipitate due to formation of this 2,4,6 tribromo. So the observation is very important in the bromine test. You have no decolorization taking place. The compound is an easily oxidizable group like benzaldehyde or any other aldehyde. If it is decolorized without any precipitate, then you have unsaturation. Okay? And if it is decolorized with white colored precipitate settling, then it is a phenol. Next, you determine the melting or the boiling point of your compound. Okay, and record the melting point. Whatever is the melting point, keep it ready. We will need it when we list the probable compounds, after finding the functional group tests. Now the functional group tests for phenols. The first test, the group test, the first test, I have discussed this in the last semester also. The first test in the functional group category is always the group test, which is common for all members of that family. And the following tests are special tests, which help you distinguish one member from the other. Okay, so the first is neutral ferric chloride test. You have to take about 50 milligrams of your compound, dissolve it in about 5 ml of water. If it is not soluble in water, then you have to dissolve your compound in alcohol. Okay, and then you have to add 1 to 2 drops of neutral dilute ferric chloride solution. Please understand, ferric chloride, which is available solution, which is available in the lab, okay, gets hydrolyzed with water, and it actually becomes acidic. So if you use this ferric chloride, you will not get this ferric chloride test for phenols. Okay, so the best thing is to prepare a fresh, very dilute ferric chloride solution, yellow color, not brown. Okay. Else, if you want to use this old sample of ferric chloride solution, you have to dilute it by adding drop-wise aqueous ammonia until the precipitation stops, and then you have to filter that. So the resulting solution will be neutral ferric chloride. So this base will actually neutralize the acid, and you will get neutral ferric chloride that you can use. Okay, so be careful. In case your compound was not soluble in water, I said you have to prepare the solution of your compound in alcohol. And in such cases, the ferric chloride solution should also be prepared in alcohol. Okay, so you will take 50 milligrams of your compound, make a solution of your compound in water or alcohol, depending on its solubility, then add 1 to 2 drops of dilute, freshly prepared ferric chloride solution or neutral ferric chloride solution in water or alcohol, depending upon the solubility of your compound. And if you observe colorations different from yellow, that is green, blue, violet, brown coloration or precipitate, then you say that the compound is a phenol. But please remember that nitrophenols and phenolic acid, like dihydroxybenzoic acid, paranitrophenol, salicylic acid, do not give these tests. You can see the color. This is dilute ferric chloride solution. This should be the color of your ferric chloride solution when you use it. Okay, and not this one. Okay. Yeah. Next, we come to phthalene test. Phthalene test is a special test, especially for actually resorcinol, confirming resorcinol. Now, resorcinol is 1,3-dihydroxybenzene. Yeah. So you have to take a dry test tube, take about 100 milligrams of your compound like that, okay, and add equal amount of phthalic anhydride and 1 to 2 drop of concentrated sulfuric acid just to moist it, okay, and then gently heat on the burner, okay, so that the solid, it melts, just melts, okay, then cool it and then add 3 to 4 ml of 5% sodium hydroxide solution, and then dilute with equal volumes of water. Okay, so if you get red coloration, it confirms phenol. However, if you get beautiful green fluorescence, it confirms the presence of resorcinol. Let us understand the chemistry of this reaction. You can see this is the beautiful green fluorescence that you will get in case of resorcinol. Okay, all the other phenols will give you some pinkish coloration. Okay. what is the chemistry of this test? Let us see if I have resorcinol. Okay. And then phthalic anhydride. Okay, when you heat it in presence of concentrated sulfuric acid, it will lose 2 molecules of water, and you will get something like this. And when you add alkali, this OH will ionize and it will form the carbon ion, sorry, an ion, corresponding oxide ion, phenoxide ion. And then it will, there'll be a delocalization taking place like this. It will go from the benzenoid form to the quinonoid form, giving you that beautiful green fluorescence. That is the color, and this, can resonate from this side also. The delocalization can take place here. Okay. So that is the chemistry of the test. The third test is the Lieberman test. This test is to find out whether the phenol has para position 3 or not. Lieberman test is characteristic of phenols with para position 3. So something like hydroquinone will not give you this test. Don't know what is hydroquinone? Then it is 1,4-dihydroxy benzene. It will not give you this test. So how you have to do this test is in a dry test tube, you have to take 1 or 2 crystals of sodium nitrite, and then you have to add around 500 milligrams of your organic compound. Heat it gently for a few minutes. You just have to use it, so that it melts. Cool it, and then add 2 ml of concentrated sulfuric acid. You will immediately see some green or blue coloration. You will understand the chemistry and know why it is happening. Very carefully, add water to it from along the side because you have sulfuric acid in this. So along the side, you add some water, you will get red coloration. And to this red solution, if you add excess of, say, 10% sodium hydroxide solution, again, the color will change to olive. So if this test is positive, the inference that we draw is that the phenol has para position 3. Okay, let us understand what is happening in this reaction. So if you have a phenol, say I will take simple phenol. So para position. Okay, it will give you para nitrosophenol. It rearranges like this, and this will combine with another unit of phenol. There will be a loss of a molecule of water under acidic conditions. Okay, and it will give you a compound that is called indophenol. And it is this indophenol which is responsible for that red color solution in water. Okay, this is indophenol. If you acidify it with acid, it will form the corresponding ion, which will be stabilized by resonance. You can see how the resonance takes place. And if you add alkali to this, it will form the corresponding phenoxide ion here. Again, that will be stabilized by resonance. Right. Okay. And this can similarly stabilize by resonance. Very interesting example of acid-base chemistry. Okay, so that is how this will give you the green or blue coloration in the acidic medium, and this will give you the green or the blue coloration in the alkaline medium. And in presence of water, you have this red colored solution because of formation of endorphin. Okay, please note that this test will not be given by nitric greenhouse. Now let us see the derivatives of phenol. What derivatives you can prepare? There are two derivatives that you can prepare. The first one is benzoyl derivative. So the reaction is very simple. You have a phenol, okay? You react it with benzoyl chloride, okay? In aqueous alkali, and you will get the corresponding benzoate derivative, which are crystalline solids. Okay, so let us understand how this reaction is taking place. Okay, so how we have to do this benzylation reaction? Let us see. You have to take 1 gram of your organic compound in a boiling tube, add 15 ml of 10% sodium hydroxide solution. Now, when you prepare derivatives, these reagents have to be prepared on your own. You don't take the bench reagent, for preparation of derivatives. So prepare 10% sodium hydroxide solution on your own. Add 15 ml of sodium hydroxide solution to the conical flask or the boiling tube, whatever you have taken. The important thing is that it should have tightly fit cork. Okay. Then you first add 0.75 ml of benzoyl chloride. Replace the cork or the stopper and shake it vigorously. Okay. Shake the contents vigorously. This is an exothermic reaction. The contents will heat. And when the reaction subsides, the contents will come back to room temperature. When they come back to room temperature, add the next lot of 0.75 ml of benzoyl chloride. So that means you have to add benzoyl chloride in 2 lots. Okay, total 1.5 ml you have to add. When you add the second lot, again repeat the same procedure. Tightly put the cork, shake it vigorously, and allow the contents to come back to room temperature. When they come back to room temperature, transfer your contents to a beaker containing about 50 ml water. Filter the content, wash well with water, dry, and recrystallize that. Okay, recrystallize from alcohol and take the melting point of the recrystallized sample. So when you take the melting point of the recrystallized sample, you have to go back and check your list of probable compounds. So for example, you find that the melting point of your compound is say 110 degrees centigrade, and you find that your compound is a phenol. So you will go back to the book. At the end, there are a list of compounds categorized on the basis of functional group. So go to phenols, look at solids and identify compounds which are coming in plus minus 5-degree range. So you will make a table, list of probable compounds like this. Okay, this is serial number. Then will be name of the compound. What is the probable name of the compound? Then what is the melting point or the boiling point of the compound? The note there. Then what is the melting point or boiling point of the melting point of the common derivative, not boiling point, because we have to prepare a crystalline derivative of the compound, common derivative, melting point of the common derivative. So that will be your table of probable compounds. So list the compounds 1, 2, 3 from the book in the plus minus 5-degree range. Whatever other compounds you get, please list them here. List their melting point or boiling point and list the melting point of a common derivative. So you have to prepare that derivative. For example, if I find that my list of common compounds, they all can be, they converted into benzoates. So I will write the melting point of their benzoates. I will prepare the benzoate, recrystallize it, and take the melting point. Once I take the melting point, I go back to this table and match it with my compound. So the compound where I match the melting point of the common derivative will be mine. So then I will be able to name my compound. This we have to do for any crystalline derivative that we prepare. This is benzoate. Next is acetate. Normally we prefer to make benzoates if possible. If benzoates are not reported for the compound, you may prepare acetate. So in a dry test tube or a boiling tube, you can take 1 ml of your phenol, add 5 ml mixture, that means 2.5 ml of acetic anhydride and 2.5 ml of glacial acetic acid, which are pre-mixed, 5 ml of this mixture you add to this. And then you reflux on a wire gauze for about 10 to 15. Okay, cool. Pour the contents into ice water and filter. Wash with water well and dry and recrystallize the sample from alcohol. Now there is a special derivative that you can prepare for hydroquinone. The benzoates cannot be easily crystallized, so we prepare hydroquinone diacetate. So in a dry boiling tube, you will take 1 gram of the organic compound, add 3 ml of acetic anhydride to it, and then 1 to 2 drops of concentrated sulfuric acid AR. Stir the contents or shake the contents vigorously for about 10 minutes. Allow to cool and then transfer to ice water with stirring. Immediately you will get colorless crystals. Filter them, wash with water, dry, and recrystallize from alcohol. Basically, you have hydroquinone. Okay. And you react it with acetic anhydride in presence of concentrated sulfuric acid. You will get hydroquinone diacetate. Okay. That will be the reaction. Next, we go to functional groups containing alcohols. Now, once we have ruled out that the compound does not have a phenol, there are 2 tests that we can do for alcohols. First is the sodium test. So in a dry test tube, you have to take 1 ml of your organic compound and you have to add 1 spatula of anhydrous calcium sulfate or anhydrous sodium sulfate. That will take all the water present along with the alcohol sample, and the alcohol samples which are commercially available, they normally have some water content. Okay, so we will put this anhydrous calcium sulfate or anhydrous sodium sulfate and leave it for about 10 minutes. And then the supernatant liquid we decant in another dry test tube. And then you add a very small piece of sodium, which is free from kerosene. And if you get brisk effervescence, it immediately confirms that your compound is alcohol, provided the phenols have been ruled out. Please note, phenols, carboxylic acids, all the compounds which have acidic hydrogen can give you this test. Now, because we have ruled out phenols and we are only doing in this category alcohol, phenols, and hydrocarbons. So once we have ruled out phenol, then we know for sure that this brisk effervescence is for alcohol. Okay, let us see the chemistry of the test. So basically what happens is alcohol being very weakly acidic. Again, this reaction will be given only by primary alcohol. The secondary and tertiary alcohols are not acidic at all. So when you react it with sodium metal is able to pull out the proton from this, releasing hydrogen gas, which is giving you the brisk effervescence. Okay? There is no reaction, mind you, with alcohol because they are very, very weakly acidic. The second test, once you get the sodium test positive, okay, please understand, only if you get the group test positive should you go on to do the special test. If the group test is not positive, you go on to the next function. That is the approach we have to follow throughout the systematic analysis of organic compounds. Okay. So next is the steric ammonium nitrate test. What you have to do is you have to take 0.5 ml of the organic compound and add 2 to 3 drops of freshly prepared steric ammonium nitrate solution. Okay. If steric ammonium nitrate solution is not available, you can prepare it on your own. You can take 0.1 gram of steric ammonium nitrate solid and add few drops of dilute nitric acid to that. Shake it, you will get an orange colored solution. To this, you can add few drops of your organic compound. And immediately, if you get blood red coloration, which fades on standing, it confirms that the compound is an alcohol. Let us see the chemistry of the test. So these alcohols will combine with steric ammonium nitrate to give you this blood red coloration because of the formation of this compound. Okay. Special test, the iodoform test. These tests will be given by alcohols like ethanol, isopropyl alcohol, or any alcohol which has a CH3CHOH group, which can be oxidized to an acetyl group. All those alcohols will give you this. So you have to take in a test tube 2 ml of water, add a pinch of potassium iodide to that, and solid iodine to get a saturated solution. So some iodine should remain at the bottom, should not completely dissolve. Once you get a saturated solution of iodine, decant that in another test tube, and to this decanted solution, add 2 to 3 drops of your organic compound, followed by addition of 5% NaOH drop-wise with shaking until the brown color is discharged. When the brown color gets discharged, you will see either immediately yellow colored precipitate of iodine, iodoform being formed. If it is not formed, then you should allow the solution to heat at 60 degrees in a hot water bath for about 5 to 10 minutes, and then remove it from the water bath and then cool again. The yellow precipitate in the test tube confirms that you have an alcohol having a CH3. Okay, so if you see the chemistry of the iodoform test, for example, if you have ethanol, and if I react it with iodine in alkali, it is first oxidized to acetaldehyde, which further reacts with iodine in alkali to first form triiodine derivative, which further reacts with alkali to liberate iodoform. And this is the yellow precipitate. Now let us do the derivative preparation for alcohols. How to prepare the derivatives of alcohol? The first derivative that you can prepare is 3,5-dinitrobenzoate. So you have to take 2 grams in a china dish, dry china dish. You have to take 2 grams of 3,5-dinitrobenzoic acid. Add 4 grams of PCl5. So if you are taking, you can't weigh PCl5 because it is highly hygroscopic, reacts with moisture very immediately. So you take 1 spatula, say, of 3,5-dinitrobenzoic acid, and approximately double the amount of PCl5 you can add to that. Mix it with a glass rod to form a paste. If it doesn't form a paste on mixing for about 5 to 10 minutes, then you can preheat water to about 60 to 70 degrees. Take it outside the lab, and you dip your china dish in this hot water bath, and then slowly you will find that the compound, the mixture will liquefy, and you will get a liquid. Okay. Once you get that liquid, you can add 4 to 5 ml of alcohol after removing from the water bath. Stir the mixture well and then heat it again on that water bath at 60 to 70 degrees for about 10 minutes. Then you transfer those content. So you will see some solid being formed. Transfer the contents to a beaker which was containing about 40 ml of 5% sodium bicarbonate. This is to neutralize any unreacted 3,5-dinitrobenzoic acid which is present. Okay. Filter the colorless crystal, wash them well with water, dry, and recrystallize from alcohol. Now let us see the chemistry of this test. What is happening here? So when I take 3,5-dinitrobenzoyl chloride and I react it with alcohol, what will happen is I will get 3,5-dinitrobenzoate. These are esters, these are crystalline solids. And how did I make the 3,5-dinitrobenzoyl chloride? I have reacted 3,5-dinitrobenzoic acid with PCl5 to get this 3,5-dinitrobenzoyl chloride in situ, which reacts with alcohol. That liquid that you get, I said, you warm until it liquefies. So that liquid is signifying the preparation of 3,5-dinitrobenzoyl chloride, which then reacts with alcohol to give you this crystalline 3,5-dinitrobenzoate derivative. Okay. Another derivative that you can prepare is, of course, iodoform. So if your compound had iodoform test positive, you can prepare slightly more, amount of iodoform, and that being a crystalline solid can serve as a derivative. So you can, for derivative preparation, we will have to do it on a slightly larger scale. Take 5 ml of water, add a pinch of potassium iodide, and again solid iodine to get a saturated solution. Then transfer it to the saturated solution to a test tube. To that, add 2 ml of your organic compound, followed by addition of 10% sodium hydroxide solution, dropwise until the brown color gets discharged. Now, you may immediately see the formation of yellow color precipitate, which increases, if you allow it to stand for about 5 to 10 minutes. If you do not see any yellow precipitate being formed when you allow to stand for about 5 to 10 minutes, then you can heat on hot water bath maintained at about 60 degrees centigrade for about 10 to 15 minutes, and then cool. On cooling, you will get a yellow colored precipitate, which you can filter, wash, dry with minimum amount of water, and recrystallize from alcohol. The chemistry I have already explained to you. If you have alcohol first, if it is secondary alcohol, it will form a ketone. If it is a primary alcohol, it will form aldehyde, then triiodo derivative, and then iodo. That is the chemistry of the reaction. Okay, now if you do not get a phenol, the group test for phenol is negative, the group test for alcohol is also negative, then the inference that we draw is that my compound is a hydrocarbon. If you have a hydrocarbon, there is no special test required. Negative test for alcohol and phenol will confirm that you have a hydrocarbon. So then we have to prepare the crystalline derivative of hydrocarbon and identify the compound. For that, there are 2 derivatives that we can do. The first is the nitration reaction. you will take, I have taken the example of nitrobenzene here. For you, it can be, say, benzene, it can be toluene, it can be naphthalene, can be anthracene. Because benzene is carcinogenic, normally we do not give it in the lab. So any of these hydrocarbons can be there. So you have to take 1 ml of the hydrocarbon, 1 ml or 1 gram. In a dry round bottom flask, you have to add 1.5 ml of concentrated sulfuric acid dropwise with shaking. And when you are adding sulfuric acid, please cool the round bottom flask in cold water boil. Okay, and follow this by dropwise addition of 1.9 ml of fuming nitric acid. Okay, and then put the air condenser and reflux on wire gauze for about 30 to 45. Check for completion of reaction. How do you check for completion of reaction? Put a glass rod inside. In a test tube, take some ice water, stir the glass rod with some reaction specific to it. And if you see the solid being formed, the nitration is over. Otherwise, continue for another 5 to 10 minutes and again check for completion of reaction. Then once you have confirmed that the reaction is over, you can cool the contents, transfer the contents to about 50 ml of ice cold water with stirring, filter, wash well with water and dry, and recrystallize a portion of the sample with alcohol. The second is the picrate. So if you have something like naphthalene, anthracene nuclear hydrocarbons, in those cases, it is very easy to prepare these crystalline picrates. You will take 1 gram of your organic compound in a dry china dish, dissolve it in minimum amount of hot acetone or ethanol, and then you add 10 ml of cold saturated solution of picric acid in acetone or ethanol, dropwise, with stirring. Okay. In case you're suspecting your compound is anthracene, you will have to, after mixing the picric acid solution, you will have to warm it on hot water bath, which is maintained at about 60 to 70 degrees centigrade for about 5 minutes. And then allow the contents of the china dish to stand in air, outside the lab. The solvent will evaporate and you will get a beautiful crystals, yellow colored crystals in case you have naphthalene and red colored crystals in case you have anthracene. So this is nothing but, reaction between an electron rich and an electron deficient species. What is picric acid? Picric acid is 6 nitrophenol. They combine together, form pi complex. They're fairly stable. Okay. And you can take the melting point of this period. You don't need to do the recrystallization. Directly, you can take the melting point and identify the compound. So today we have learned how you can systematically do the analysis of compounds having alcoholic, phenolic group or hydrocarbons. So now you will carry out these tests systematically and identify the unknown compound which is given to you.